Hi, and welcome to another installment of Oregon State University's 2020 Virtual Field Day. My name is Chaz Schmid, and I'm a research associate at Oregon State University. In this video, we're going to discuss the long-term cultivation and sand top dressing trial initiated this spring at Oregon State University. So some of you may be asking yourselves, why do we need another cultivation study? There's been plenty of them in the literature in the past. I've done some work with Rock Gaswa at the University of Nebraska looking at solid tine versus hollow tine, as well as some venting treatments during the summer. Jim Murphy at Rutgers has done some work with sand top dressing size as well as cultivation in the past. So you may be asking yourself, why do we need this? Why do we need more studies looking at cultivation, organic matter, and infiltration? And part of the reason why we started this trial is if you look at the literature, there is a lack of information on cultivation effects on annual bluegrass putting greens. Most of the research has been done on creeping bentgrass, and if there is any research on annual bluegrass, it's in mixed stands with creeping bentgrass. The other thing is there is also a lack of information on annual bluegrass putting greens in the Pacific Northwest. Specifically in the Willamette Valley in Oregon, we have a growing season of 12 months, so the annual bluegrass is growing all winter long. We don't get dormant periods like you see in the Midwest or on the East Coast where you get snow and the grass goes dormant and you don't see growth. So in the Pacific Northwest, we have 12 months of growth. So some may make the case that we would need slightly more cultivation to manage the 12 months of growth versus 8 or 9 months that you would see in the Midwest or East Coast. So the objective of this trial that was initiated this spring are one, to evaluate the long-term effects of hollow tine cultivation versus solid tine cultivation on annual bluegrass. And when we say long-term, we're looking at a 5-year study in this case. Two, we want to evaluate the effect of cultivation timing, being either spring versus fall versus both spring and fall on organic matter and infiltration rates. And then finally, we want to determine the effect of sand top dressing rate on annual bluegrass putting greens, and then to determine if they interact with cultivation type and timing. If we can apply a heavier rate of sand top dressing, can we get away with one cultivation either in the spring or fall, or because we have the longer growing season, do we need to have the higher top dressing rate in combination with cultivation twice a year? The site for this trial is an 11-year-old annual bluegrass putting green. It was constructed using 11 inches of USGA spec sand placed over a silty clay loam soil below it. It has flat drainage in this green. And as you can see by the picture on the right here, I would consider this moderately thatchy or fairly thatchy green that we're working at here. You can see a fair amount of thatch at the surface. You can see the mat layer that's developed here over the original root zone. And then we have the lighter colored sand, which is our original root zone on the bottom here. This is a long-term trial, so it'll be conducted for 5 years. And it's designed as a 7x2 factorial plus a non-treated control. So a control treatment that receives no cultivation and no top dressing. Our main factors for the trial are cultivation. So we have both cultivation type and timing within this. And then we have a top dressing rate factor as well. Treatments are designed in a strip split plot design with 4 replications, and the whole plot in there, or the strip, is our cultivation type, and then our subplot or our split plot is our top dressing rate. Listed below are the treatments included in the cultivation main effect. As I mentioned in the previous slide, we have a couple things going on here. First is the cultivation type, so either hollow tine or solid tine. Both these tines are the same outside diameter, roughly 0.6 inches. And then we have a timing effect within here. So we have either spring only, fall only, or a spring and fall treatment for both the hollow tine and solid tine. We included a no cultivation treatment in here as well, and these treatments receive top dressing during the summer at both of the rates. On the right, we can see our 2 treatments. Both are hollow tine on the left, solid tine on the right. Our hollow tine has quite a bit more material left at the surface, obviously, from removing the cores, and we would come back in and try to blow off as much material before we would backfill the holes with clean sand. On the right, the solid tine treatment is relatively clean, as we would expect. So what was interesting about this is we backfill each plot individually, and we measure the amount of sand we put on the plot. So we're able to determine how much sand each plot takes in to fill the holes. And what we found was that the solid tine plots actually take in more sand than the hollow tine plots. And this can probably be explained by the fact that sand falling off cores are getting back into the hole, so we're not getting as much clean sand in here. So not sure if that's a big issue. That's something we'll kind of look at in the future and hopefully be able to pick up on either in organic matter samples or any of our infiltration data. The second factor for the trial was sand top dressing rate during the summer. We chose two different rates, either 50 pounds or 100 pounds per 1,000 square feet every 14 days. These rates came from previous research done on annual bluegrass putting greens by Dr. Rennie Wong. Rennie did a virtual field day presentation earlier this week talking about sand top dressing rate, so I'd encourage you to watch those videos if you'd like more information on sand top dressing. Pictured on the left here, we have our sand top dressing rate on the surface right after application, but just prior to brushing. We have 100 pounds per thousand on the left here, and our 50 pounds per thousand on the right. Once these treatments are brushed in, they work into the canopy nicely, and you can't see any sand left on the surface. To date, we have not filled up the canopy and had excess sand sitting on the canopy after a top dressing treatment. So this would indicate how thatchy these greens were prior to the initiation of this trial. Also need to mention that we included a non-treated control in the trial, which received no cultivation and no top dressing throughout this trial. This is different from the treatment I mentioned on the previous slide, which received no cultivation but receives both of the top dressing rates during the summer. So a little distinction between the two, and we're able to compare doing nothing at all to just top dressing as an additional comparison. So since this is the first year of the trial and we still haven't completed a full set of cultivation treatments yet on the plot, we don't have a lot of data to present, but I wanted to spend a little bit of time talking about our sampling procedures and what data we're going to collect for this trial. The first and most obvious one we're going to collect is organic matter. We've decided to use slightly larger soil probes to collect samples. This is an 1.25 inch soil probe. And then we're going to stratify the sample into several layers. So some of you may have heard of this method out there, looking at total organic matter. So we're going to include the leaf clippings, the thatch, and everything in this 0 to 20 millimeter sample. So this will really give us an idea of how our sand top dressing treatments are influencing organic matter at the surface. Then we're going to look at a 20 to 40 millimeter layer in here, and then our 40 to 60 millimeter layer. So these bottom two will give us an idea of how our cultivation treatments, either solid tine or hollow tine, are influencing these lower layers. So we'll be able to look at each layer individually and hopefully see some more subtle changes in the physical properties of these soils. We're also going to be taking infiltration rates several times a year, once early in the spring prior to our spring cultivation treatments, and then once in the middle of summer when we're under the highest pressure and the turf is the weakest. So what we're going to do here is a falling head double ring infiltration. So we put water in the inner ring and outer ring. We know the certain volume that we'll take to measure an inch up the side, so we fill them with that water. And then we time how long the center ring takes to infiltrate that inch of water, and we'll record that time. We do this process 3 times over. So the first infiltration rate will be under whatever the field conditions are at that point, whatever your moisture is. By the time we get to the third infiltration, we'll be more towards field capacity, or soil will be saturated, so we'll be able to determine saturated flow. So that's the reason why we're looking at 3 different inches of infiltration, and we'll be able to compare treatments at each increment of infiltration that we measure. So that will be very handy. And then we'll also look at the turf surface. So we're looking at surface characteristics. On the right here, we have the true firm. So this will be able to determine surface firmness, or how hard the surface is, and how our top dressing and cultivation treatments are influencing the surface. We're also going to monitor other things such as visual quality of the plots, any kind of differences in disease pressure moving into the plots. We'll also note as well in this trial. With that, I'd like to thank you for watching our video on the long-term cultivation and sand top dressing trial. Also like to remind you of our virtual field day Q&A held via Zoom on September 2nd of 2020 from 9 a.m. to 11 a.m. Pacific time. And I'd also like to take this opportunity to thank our sponsors and funding agencies that have supported this research, including Turfstar Western for the donation of the Procore aerifier used in this trial, as well as the GCSAA, the Oregon and Northern California chapters of the GCSAA, and the Northwestern Turfgrass Association.